Welcome, everybody. It's really a pleasure for me to see full house at IU University to talk about mathematics. This is really exciting. I see lots of young people here. And again, I welcome you to this act that we're organizing this afternoon as a joint collaboration between IU University and the Royal Spanish Math Society, Real Sociedad Matemática Española, with the title of Mathematics in the Era of AI. So without further ado, I'm going to introduce the people that will be part of the panel that will be discussing these really interesting topics. So we're really honored to have Professor Marcus du Sautoy from the University of Oxford. Marcus is a researcher in number theory and in group theory, and he's also an excellent disseminator of science. He's got written plenty of books, lots of documentaries. We had an excellent talk by him this morning, and I think he's one of those people that actually makes you love math. So we're really happy to have him here. Eva Gallardo is the president of the Royal Math Society, and she's representing the society in this very interesting talk. She's a professor at the Universidad Complutense in mathematical analysis. And Eduardo Sáenz de Cabezón is a professor in Universidad de La Rioja. Also an excellent science disseminator. Perhaps you know him from TV. He's got a program called Orbita Laica, YouTube channel, Derivando, where he's got lots of nice videos about mathematics. And again, we're also very happy to have all of them here. And the whole act is going to be moderated by Irene Alda, who is the academic director for the Bachelor in Applied Mathematics at IE. So I welcome you to the board. Yes.
Okay. All right, well, good evening, everyone. I think I can sense the excitement in the room. It's really nice to see so many students, researchers, mathematicians, hopefully future mathematicians. And a little bit in this sense, the first thing that I wanted to do is thank the whole team at our school, the School of Science and Technology at IE, as well as the support from the RSME to making this event possible, because without the whole team effort, we wouldn't be here today. So getting a little bit into the topic, and given that I see a lot of very young faces, I'm going to go to a story of a friend of mine when she started studying mathematics. And one day, just chatting, she said, wow, this is very different from what I expected in the sense of what I was seeing in high school or at school. And I was very used, she would say, I was very used to the whole computational aspect. And now I see that it's a little bit different. It's more conceptual. And with this, this story reminded me a little bit of what I've heard Eduardo shared in some interviews, is that when he teaches undergrad in the first year, that many of them are very good at computing or obtaining a derivative, but when they're being asked, what is a derivative, they go a little bit blank. And so a little bit around this, how, Eduardo, do you think we can bridge that mathematics that is being taught before university to university, so students aren't like so, let's say, shocked?
Why me? Why am I the first one? How can we bridge the mathematics in high school or mid-school to university? Mathematics, well, mathematics in university, in a mathematics degree, is more focused now on understanding than it's normally taught at school. So I guess at least the first tone of the bridge is don't substitute understanding by computing. Computing shouldn't be a shortcut. Or a substitute for understanding. I mean, sometimes we do, okay, I don't know how to do this, I don't know what is this, what does it mean, or get a deep understanding of that, but I can compute it, so I'm done. So this is the math. It shouldn't be a substitution. Sometimes computing helps understanding, and the other way around. But I think our goal is to engage our students with the mathematics, with everything they study. In particular with mathematics, you learn more and learn more deeply when you are involved in the learning process. And to get involved in the learning process, so understanding is a good way to get involved in the learning process. So I think sometimes when there are some people, I don't know if you know somebody that hates mathematics. There are some people over there, out there.
Surely not.
Yeah.
Surely not.
Not here, not here.
Or are afraid of mathematics. I don't know. There's some people out there. I found one once that they hate or are afraid of mathematics. And I think there is a point in school when the focus is more on the result than in the process. And that helps fear of mathematics, because then there is many ways to fail and just one way to get it right. But mathematics is not that. And mathematics is more about the process, and the result is part of the process. Maybe sometimes it's the final part of the process, sometimes it's the starting point, but it's part of the process. So when you focus more on the process than in the result, then mistakes and errors are very useful friends for learning. They're not errors are not someone to be afraid of. And I think sometimes fear comes from this focus on the result. Mm-hmm. And I would say mathematics in school and is more focused on that, and mathematics in the university is more focused on the process and on understanding. And sometimes our students in the first year, it's a valley of tears, as we say, because they come, now in mathematics in Spain, people come with a very high mark from school. So they're the top ones in high school. They come to the mathematics faculty degrees, but these people, it's not only that they probably never failed an exam in their whole life, it's probably that they never had a mark below 8 or 9. They're the elite. And then they come to mathematics and they may fail 4 out of 5 subjects. So they say, I lost my chispa, I would say. I lost my spark, I lost my ability, I'm not good at this. Then they are devastated. But they shouldn't be, because they just need to change the way they are confronting the subject. And has to do with understanding and the role of the result of the product of a problem.
Yeah, so this brings us a little bit to I would say, the methodology, and we chose a very provocative title for today's event. This is something that we've been a little bit discussing, I would say, throughout the day. So, Eva, how do you think that AI can really support students in their learning experience? Today we're talking about mathematics, but it could really be applied to other fields, and not hinder that process of being able to be critical about what they need to learn.
Really, this is the second stone in the bridge that he mentioned. Actually, what's going on is that you don't learn things just in an abstract way. You need a source of examples, a source of testing examples that lead you to make abstraction, to understand theorems or results, but not only mathematics, in all sciences. So in that sense, IA can serve as a test for, as a source of examples where you can test your knowledge. For instance, I was trying with some integrals. They can be really tough to compute. For the students first year, or even in complex analysis that I taught, I was testing some integrals, and they give you the correct answer. So it's something that it can be used in order to test yourself. That must be, on the other hand, you must be careful about, because sometimes it gives you a lot of wrong answers. So it can test you also in the wrong way. I mean, you can think that you were right, but that was not the case. So that's something, I mean, carefully in that direction, right? You need to be careful about. But I think the strong is not only that you could be good at computing. Yes, the idea is also that you should be able to abstract the consequences of the process that he was mentioning in the knowledge, in order to get not only the result, but also the knowledge. And that in IA, it can be very, very important, I think, to get the knowledge. If you make simulation, if you program and you want to test, that's important in order to learn things and to even to promote theories that you say, okay, this should be the right answer, right? So in that sense.
Yeah, I think it's really difficult to discern, though, especially when you're learning, like
Mhm.
if this is a correct or an incorrect answer. So I guess we go back a little bit to that conceptual part more than the computational part, which in the
That's
end, when you
true.
give a prompt, is that you can ask, for example, ChatGPT or any other AI tool to perform a given task, but sometimes it might brute force it and not do it in an intelligent way that if you know some mathematics, it will do it better. And this kind of reminds me in a way to what Marcus was sharing in this lecture earlier this morning. No, he spoke to us about the art of the shortcut, not as in cutting corners, but in really finding, I would say, the gems or discovering nature's language in a way, to providing ways that we then teach at school how we calculate things, but from that deep understanding. So it really reminded me when you said, "Oh, I was a lazy teenager, and I wanted to find these shortcuts." So, in a way, what do you think drove you there for mathematics, given that to that curiosity for finding those shortcuts?
Yeah, well, I think for me, we need to recognize that AI is a really new, powerful tool, the tool for doing things. So, and I often compare it a little bit like we've suddenly got this new telescope, which can help us to see deep into data, digital data. It's a bit like Galileo had a telescope and suddenly saw deep into the solar system, started seeing things that we'd never been able to see before. So for me, I think this is the power of this new tool for science, that, you know, we have a huge amount of data being generated, for example, in CERN, in the Large Hadron Collider, or in mathematics, we're generating computationally a lot of interesting kind of numbers out of the structures we're looking at. And what I've seen is that what AI is very good at is spotting patterns. And actually, mathematics is very often about spotting new patterns, and then you try and explain why the pattern works. And for me, that's what's interesting, that we need to see this as a great new collaborator, because where I've seen AI really important in mathematical research is in understanding new conjectures about structures that we've not been able to see just because we just can't cope with that amount of data. But what AI is not very good at the moment is explaining why there is that connection. So there was a very good paper which people should have a look at, which was published in Nature in the end of 2021, which is a collaboration between DeepMind, who are the people that developed AlphaGo, for example, who could play that game of Go against Lee Sedol. It was kind of the emergence of how powerful machine learning could be. But it was a collaboration between DeepMind in London and some mathematicians in my department in Oxford. And they were looking at something called knot theory. So the structures you can make with knots, which have very big implications for physics. But the AI had spotted a new pattern in kind of invariance of these knots. But it couldn't explain why this pattern was there. And I think this relates to what you said, actually, that you know, very often these tools can be just spit out an answer, but you need to have understanding. And what humans are very good at is then putting the story behind that new observation. So the AI is good at making, you know, these new observations, but it's not very good yet at explaining the story. And I think, and actually we see that even in artistic disciplines. ChatGPT is very good at generating a few paragraphs of very convincing text, but I've never seen it do anything beyond about, well, maximum 10,000 words of something that's interestingly coherent. So, you know, a novelist writes 100,000 words. It can't write a novel yet. It just meanders. It's like a stream of consciousness. And for me, you know, a mathematician is a bit like a novelist. Our characters are numbers and geometries, and we tell big stories about these things. And AI can't do that yet. AI can spot these kind of interesting new kind of patterns, but where I think it's that collaboration. Suddenly we've got a tool to see new things we didn't see before, but still the mathematician is the one who's got the expertise in actually telling the story to explain it. It's interesting that ChatGPT is pretty rubbish at maths in certain circumstances. You know, because it's basically just done on a statistical level. So, you know, if you ask it, okay, two people take 1 hour to plow one field, how long will it take 4 people to plow 2 fields? Well, it sees everything doubling up, so it says 2 hours. It doesn't realize it's actually still 1 hour because each one is doing it in parallel. So it doesn't understand the kind of, it's not good at formal thinking because it's doing everything on a statistical level. So that's kind of interesting. I think ChatGPT is very good at creating code. If you ask it to write code, because that's its natural language. But weirdly, it's not very good at necessarily at formal thinking. It makes really weird, basic mistakes.
And you mentioned the idea of having a story or a little bit about context around math. And I've read somewhere that you've said it's your dream that math, in a way, would maybe, when it's being taught, that it's not so distinguished from other, let's say, courses. So how could we make, maybe that's very difficult, but how could we, let's say, blur those limits a little bit in education?
Yeah, I think you're doing it already quite well here from what I've learned today, which is, I think education suffers from having this silo mentality, and it starts pretty much at 11, 12 when you go to secondary school, where suddenly you're going to the maths class, the history class, the music class, the science class, and there's no attempt to integrate these and to show that maths is, the heart of musical composition, or it has a history. There are people who discovered these things. I think that's the way to sort of draw people in who aren't natural mathematicians, who are perhaps more comfortable in the humanities, is like, let's smash down the walls between these subjects and find a way to really integrate them. So I think that's what, universities can really play a big role in that, and just, integrate. I was talking to the students who are doing applied maths, but that is so integrated into the architecture that's done here, the design that's done here, industrial design. So I think that's, for me, one of the things we need to change in our education system.
And I mean, the 3 of you are professors, and how have you seen how mathematics is taught throughout your experience, I would say, both as a student and now as a professor?
How's it taught? In many different ways, I would say. So there's many different ways to teach math. There's many different professors. There's many different teachers. One thing I see with hope is that math teachers at the secondary level and the primary level, they make more societies and groups than teachers in other subjects. So they're very interested in improving their way to teach mathematics. And I think
so they share.
They share a lot. And there's the Society for Math Teachers in Galicia, in Spain, in Andalusia, whatever. They join a lot, much more than other subjects. And I think there is a honest aim to improve the teaching of mathematics. And I think this has an effect. And mathematics is taught better and better every year. I think this is a reality in our country and in other countries, because they're really making an effort. And it goes probably in the way that giving more context to what we are doing. And I think,
well, what we're suffering from in the UK is that most maths teachers in schools, maybe it's better in Spain, but they don't have a maths degree. So when a student asks, why is minus times a minus plus? They say, oh, it's just a rule. But it's not. You can prove why minus times minus. And do you know the degree that most maths teachers in the UK have? It'll surprise you. It's not a science, it's physical education. Because the teachers who are doing the sport get a little bit older and they can't keep up with the students. And they say, we've got no maths teachers in our school. Would you like to teach maths? And they say, we could pay you a little bit more money. And so, we have a real challenge with, if you want to deeply know about your subject, the trouble with it, if you do a maths degree, to all the students out there, it empowers you to do whatever you want to do. It's the most powerful degree for, opens up the world to you. So unfortunately, maths teachers don't have high status in the UK. There are so many other things you can go and do, get better paid, be treated better. And so we are having real difficulty drawing the mathematicians back into the classroom to be able to spread their love of the subject.
On the other hand, what is also true is that what Eduardo said, somehow mathematics now are living a golden age in many sense. We're having now the best students in high school, and they want to become mathematicians because all the implications that they had, probably because they are very well paid in companies and they get a lot of jobs, right? But also that implies that they are more curious. I mean, it's not the same when you have very motivated students than when you have less motivated students. That's part of the story. And I think teaching has been developing in that sense. I remember when I was a student, I had old-fashioned professors at the university, and they could spend 1 hour explaining a theorem, no motivation behind. You had everything, the epsilon, and then you had the delta. Okay, the very, very strict way to. Now, I think that changed, or it's changing. Of course, you always have old-fashioned way of doing things, right? But at least I think you try to motivate. And there are many professors in the faculty. The young people try to motivate. Why are those things interesting to be studied? What is behind? And clearly, at the end, you need some formalism. You need to prove things or whatever. But in that sense, my impression is that when you get more, when there is a demand on yours, because you have a student who are asking for more, of course you have to prepare yourself more. In order to provide better answers, right?
Can I just, one thing, maybe I have to do with, I'm curious about this. There's many people who want to study math here in Spain now. And it's difficult to get into the math degree because there's lots of people who want to do that. And the reason is probably because there's a high employment rate in mathematics, and they do lots of applications in AI and data science and so on. So I'm missing the people who are in our degrees and want to be a math teacher. They're out of our math degrees, they're out. And also some people who are maybe very keen on mathematics, on the abstract mathematics, they love math. For the sake of mathematics, they may win a gold medal in the math Olympiad. If they don't have top marks in English, history, whatever, they are out of the math degree. We're missing them. I miss them in my lecture room. Is it the same? I don't know. I'm feeling a bit worried about this. So it's a golden age in some aspects, in some respects, but in some other respects, I really miss these people.
Yeah. I think there's a role actually for universities like this to play, because a university like this depends on having good students coming through. So actually there's a responsibility for universities to help schools with the teaching and the instilling the love of mathematics. So, I've seen some very good projects where we get students who are in schools that don't have enough good maths teachers, and we bring them into the university and provide the kind of deeper learning. And actually they're introduced to university-style life, and they actually benefit from that on top of the mathematics. Or the other way around, I do things where I send my students into schools, which is good for them because they learn about communication skills, things which mathematicians aren't always very good at. But by going into school and saying, okay, you got to do something to excite these kids who are, like 15-year-olds, they're a tough bunch. They're the hardest people to talk to because they're like, I don't want to show any interest in this at all. So you've got to work really hard to do that. But then, they see kids that are not too far away from them, like in their 18, 19, 20, coming in and enthusing about the subject. That generates a really good sort of energy. And so I think it's sort of win-win situation. But, too much we see the schools separated from university, and there's this big jump. And I think, finding ways to do tentacles both ways could be an answer to this problem.
So in a way, having role models.
Yeah, role models is really important. So,
yeah.
But on the other hand, the good students, for instance, in France, math was always for the good student. You have the normal year, right? The École Normale, and you have very good teachers at the secondary. So it's a problem that we're suffering here, or I don't know if in Italy or Greece, but at least not in other countries in Europe. France is just something completely different because the best students always went to study math, and they have wonderful teachers. So I think the problem has to do also with the system, the institutional system. What happens? Not many students who are interested in math can get into a math degree or math faculty because there is a limit of numbers. But that's as easy as open more positions and open more degrees. So that's probably one of the solutions. I don't know if it is the easy. Of course, it's not the cheaper.
Okay.
So what would you say that these students that are going to study math, what traits or should they have?
Passion, for sure. If you want to study math, you need to be passionate about math. I mean, this is that I think, okay, for me, it's a matter of passion. What else? I can still emotionate when you see something. How can this be true? I mean, this is something about passion. I think all the connections that math can give you up, all the perspective in not only in science. Someone can say it's the language of science. It's but connections with arts, with literature. It's a passion, right? It's something, and it's an invention of the man in some sense. So this is the big question, right? Is this an invention or not? But this is my perspective.
Yeah. I think this room will be biased, but I'm really curious to know the answer. Who is passionate about math? Yeah. And I have another question. Someone that, let's say, passed that passion onto you, whether it was a teacher in high school or like this mentor or role model? Okay. So going a little bit back to this, I think it really connects with the idea of the secondary school teachers. And what would you say is, well, first of all, did you have a similar experience of it being a secondary school teacher that really ignited that passion?
Yeah, no, I had a teacher who did something very clever. I just went to my local state school, but when I was about 12 or 13, this maths teacher took me aside and started saying, you know, what we're doing in the classroom is not really what mathematics is about. All these sines and cosines, long division. Actually, that's not really mathematics. That's the kind of technical side of it, but it's the really boring side. And he started to explain all of these other things to me, like prime numbers, Fibonacci numbers. They weren't on the curriculum, or topology, symmetry. And he just ignited this kind of, he started to tell me the kind of big stories of mathematics. And that was really exciting. And I think that's what we miss. I think our curriculum, I think secondary school teachers are boxed in by, certainly in the UK, by an incredibly boring curriculum, which is very technical, proving things which are like, we teach our kids, my kids went through school, learned how to solve a quadratic equation. They are never going to use that in their life, ever. So what is the point of teaching them to solve a quadratic equation? It's not about the ability to do that. It's about a way of thinking. So I think we've got really mixed up about the utility of maths. And the maths we teach in school, we say, no, it's the useful maths. It's the technically, but actually it's not that useful. A sine or a cosine. How many of you have ever used a sine or a cosine? Okay, but you're a technical, I mean, I think the only time I ever used it was measuring. I had to measure how much tarmac I had to put on a roof or something, and I measured an angle. But that's kind of. So I think actually we need to let off and say, there's a very basic utility of maths, which is about facility with numbers, and that's certainly true. But I think actually the maths that sort of goes beyond that we should let off that and actually choose the beautiful maths, not the maths that we think is useful, because I don't think it really is. And we should actually, you know what my proposal is? That we should, in my kids when they went to school, they did English language and English literature. In the English language, they learned how to use language, grammar, spelling, how to write a letter. In English literature, they got exposed to Shakespeare, romantic poetry, Animal Farm, George Orwell. And they got fired up by the subject, by that bit of it. That's what made them want to read and things like that. In maths, we got maths language, but we need to create a maths literature, a maths of the big stories about prime numbers, about infinity, the fact that there is more than one sort of infinity. We teach that to our undergraduates, but the maths is simple enough. You can explain it to a 12-year-old. Honestly, there's no technical side to understanding why there's one infinity bigger than another. Nothing beyond what you could 12, 13, 14-year-old can understand. So why aren't we doing that? Well, the government will say, but they're never going to ever use the fact that there are two sorts of infinity. Yeah, but actually, did you realize they don't really know how to need to solve a quadratic equation either? So do the interesting stuff, not this kind of technically boring stuff.
Yeah, connecting things with other subjects, as you said before, because we learn by connecting the new knowledge to the previous one we have inside. And if we like something, if we love literature, poetry, music, and then your math teacher connects math with things you like, it's easier for you to understand what the math is and to connect to your previous knowledge, and also to get passionate about it. Because then you see math is not a bubble that's outside there, only that begins and ends in the classroom, but also is connected to your life. And it's not only useful. Some people are very focused on the utility of mathematics. That's great. It's lovely. But some other people can make this connection by another side. Like, oh, I love it. It's fun, or it's curious, or whatever. And they can make this connection to what they actually love. They already love.
Yeah. Do you know that Shakespeare, for example, uses prime numbers very significantly in the way he wrote? So, a student who loves English literature, who starts to see, actually, but Shakespeare was sensitive to mathematical ideas. So, if you remember your Shakespeare loves writing iambic pentameter, which is 10 things in a line. Well, what is the most famous line of Shakespeare? To be or not to be, that is the question. It's 11. And you go, oh my gosh, what's happening? And you wake up, and Shakespeare did that on purpose, because if it's just da 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 da, but there was an extra beat, and it wakes you up. So he's using that mathematical structure to say this is significant. You need to listen to this bit. In Midsummer Night's Dream, whenever there's magic being used, it goes down to 7 syllables. So 7 is his number to indicate the involvement of magic. So these numbers are being used as code inside that literature. It's those kind of things that we need to tell students that are perhaps a little, there are students who just love maths for the sake of maths, but I'm after those students who didn't get what the point of maths is. Mm-hmm. But if you start to illustrate that, and they're interested in poetry, they say, okay, I can use mathematical ideas to do something interesting in poetry. Then, exactly, you start to draw them in.
Mm-hmm. Eva, is there a trait that, I mean, I don't know, did you have an experience like this with a professor when you were younger?
Okay, I have a wonderful professor who made connection with something completely different. It was math and flamenco. So now it's becoming very popular. And someone told me a few days ago, there is something coming up. I thought that was, but that's something very, very deep. And I used to like a lot. I like classical guitar and so. But in that sense, it's clear if you have a professor that makes connection, it basically wakes you up. That's for sure. I mean, that's. But besides that, someone who wants to really persuade a mathematic career or being a mathematician, even with apply some implications, study, I think he needs to feel passionate about.
Sure. Okay, I'll summarize a little bit. So we said the context, giving students the context to understanding why what they're seeing in their math class is important, touching upon a subject that students can be passionate about. And so my question is, students in the end get evaluated, and that puts some constrictions that they need to know certain concepts, because sometimes it's, of course, the school tests, but sometimes there are some standardized tests. So how do you see that challenge of putting this context, igniting more of that passion within the curricula? Because, of course, that's like a bigger political problem, but what can we start doing? I mean, Eduardo, you mentioned
designing the evaluation is the key point when teaching anything, because what you would like to, normally students in school and university, what do they want? Pass the exam. That's what they want. Okay, and that's good for them. I mean, that's normal.
It's fair.
It's fair.
Yeah, it's normal. And they want to pass the exam. What do teachers want? Hopefully, that they learn. So let's put these two things together. So let's let's evaluate in the way that they learn in order to pass the exam. Because they want to pass at the end. And some of them, this is just a very schematic, but there's some of them, of course, they want to learn and so on. But you have many subjects and many things that you want to pass your exams. So if a good evaluation design helps to join these two things together, learning and having your mark, your degree, so that you pass your exam. And I do think we do have a problem. That evaluation is not well designed. I think it's designed just to give a mark that you fall into the university or out of it, or into the degree you want to choose out of it. And our students, it's my impression, I'm sorry, and in the last 2, at least 3 years of the secondary school, they are focused on one single week of their lives, which is the selectividad. And that drives the whole 3 years of, last 3 years of secondary, and that is wrong. I feel it very wrong, because then you separate the learning from the passing subject. I think evaluation is a key point. I think it's a key point.
Because in the end, you need a grade in order to access the study that you want. I don't know.
I think we've got a really important issue in education, which is, we call this mathematics in the age of AI. AI is going to be, it's already causing a phase change in society. And, it's compared to the Industrial Revolution of the Victorian period. But that revolution was slow enough that it just affected from one generation to the next. And the next generation had new jobs. This revolution is happening much faster. This is happening over a decade. What a job is this year, in 10 years' time, will not be a job. It'll be a completely different thing. So we have to equip our students to be very fleet of foot, because they're going to have to change and retrain probably every 10 years into something different, which is kind of an exciting opportunity. Our generation, we got sort of stuck doing the same thing and didn't have the chance to reinvent ourselves. But to be able to do that, to be able to retrain, to be fleet of foot, to change who you are, we got to teach students how to learn, which is, I think, related to your point. That's what teachers want. We have to teach them the skills to learn new things, not the facts of a subject. They won't be important in a few years' time. We have to teach them to be able to, we don't know what it is they're going to have to learn. They have to learn the skills to be able to learn continually through their lives. And that's a really different, I think, viewpoint on education, which we're going to need to be a kind of shift in how we equip our students for the future.
So would you say that's the future of education going, let's say, in the next 2-3 decades?
Yeah, I think, we got to start 10 years ago in really giving people, and I think that's the trouble of this exam-motivated education system, which has been forced, certainly in the UK, on schools by government because of testing and grading schools. This has forced teachers having to teach to the test, not teaching learning about the subject. I'm afraid teachers in the UK are equally obsessed about the exam in that last week, because that's what they're going to be evaluated on. And I think it's completely corrupted education. I would say just scrap all exams, and let the teacher, actually that was one of the benefits of COVID and the pandemic, because exams had to be scrapped. Actually, the teachers were left to evaluate, and they've been seeing the students for many years, and they were able to give a much better assessment than this, small little window at the end of a 2-year period when they were given exams and judged that way. So, I think there's maybe we should, scrap this idea of this one exam at the end of the year and actually have a much more holistic evaluation going on continually.
So will the lecturer be substituted by AI?
No, the lecturer will be assisted by AI.
Exactly.
This is not artificial or this is augmented intelligence. It's helping us to be intelligent in new ways.
Yeah, I agree with that. It will be a collaborator in teaching. But regarding the gradings, or regarding the point of how to test the students, one thing which is clear, of course, that's the key point, but we need to test them. We need to certificate that they learn some things. So this is a big point. Somehow you are telling the society someone is ready to become a doctor, a medical doctor, because he learned the basic things, And clearly you teach them, maybe he learned or not, because you teach them better or not. But you need to certify that he is becoming someone who is proficiency or who can develop a career. And this, for me, is something really deep and make me ask a lot of questions when you're grading. Okay, if the guy is good, it's good. There is no point, right? But if the guy is not that good and he cannot pass or pass, those are very difficult. And it's a question of being honest and being conscious, because I'm saying this guy is ready. Mathematics, that's an advantage. It's a big advantage. I don't have a patient in the operating room just opening
Open heart surgery. No?
This is because if I make a mistake, that's probably I can make it, that very likely, there is no consequence, or at least not that big consequence, right? But you're certifying someone is really prepared to develop, and this is not only a matter of being, of the evaluation. It's also not only the system, it's also that you're certifying. So here there are several perspectives.
I think that in education, the different goals for different situations. A medical school is not a secondary school. And you, of course, are preparing someone to be a doctor. You need to certify. I wouldn't like to be, oh, yeah, I'm passionate about medicine. I love eyes. Just operate this eye. No, this is not what I mean. But what is the goal of secondary school? That people go out of these years learning things, of course, learning stuff. Otherwise, you don't learn anything. But the outcome should be learning how to learn and a passion for learning more. That's the outcome of secondary school. This is not the outcome of the medical school. The outcome of medical school is a different thing.
So this is why I was saying it's different if you're focusing on secondary school than if you're focusing on in the university system, how to grade and what to certify.
Yeah, sure.
And that we should be careful about. Very, very careful.
So I really like that you mentioned the word mistakes, because I think that the word mistakes. So I think students are afraid of making mistakes. And we've talked about this a little bit today and yesterday, that mistakes really, it's where you learn, right? If you get something right, you don't pay that much attention. If you get it wrong, you're like, oh, what happened? So you really dig more deep. So I wanted to, I wanted to finish on this topic because I think it makes everyone feel more relaxed if it's, okay, I can make mistakes. Just if you could share a little bit of your experience with mistakes.
There are some companies that do a mistake of the day, a mistake of the month, in particular computer companies like Google or this kind of thing. Because creating an ambient in which mistake is welcome and is something not desired. You don't want to make mistakes. But when you can talk about your mistakes, because if it's an ambient in which mistakes or errors or mistakes are something to hide, something to be afraid of, then maybe you made a mistake and then you hide it, and that is worse, much worse than if you're open to it and mistakes form part of the process, and then you can learn of mistakes. It's not automatic that we learn from mistakes. We learn from mistakes if we want to learn from mistakes, and if we know how to learn from mistakes. It's not automatic. There's plenty of people who make mistake after mistake and don't learn anything about it. So we need to know how to learn about mistakes and
so we don't
create
repeat the same mistake.
They keep on making the same mistake. To create an environment in which mistake is part of it, and we can talk about it, and it can be useful.
I think this is one thing that we can learn from AI, because the reason that AI has suddenly been very successful, machine learning, an algorithm only becomes better once it makes a mistake. Then it updates its parameters to understand, well, how could I get that right the next time? If it gets the thing right, it doesn't mutate and change. So that, we understand from machine learning is so powerful because it learns from its mistakes. So maybe we should take that story and understand that that's actually, as you said, you only really learn something when you got it wrong, and then you then question, why did I get that wrong? What's my misconception about this whole thing? And that's when you will update your algorithms to get it right the next time.
And you have to accept them. Those are part of the human being. I mean, I think that the mistakes you can make is part of your daily life, is part of being a human. I don't know anyone who cannot make a mistake. So you learn when you accept them. That's part. And this is like a sports, right? Nobody really try to run 1,000 meter, right? You need to train. You need to learn, and you can make mistake, and you can learn how to improve yourself, and that's part. I can make mistakes. Sometimes it's worse when you make mistakes in front of your students. But then I say, oh, come on, you didn't tell me I made a mistake. You didn't realize. So don't believe everything I say, because I'm not God. I mean, that's, so this is the worst part in some sense from your ego. But when you try to tell them that this is something natural, I can make a mistake, of course, every day. And I try not to make a mistake in front of my student, but if I make a mistake,
okay.
I can accept, of course it was not on purpose, right? I mean, I didn't try to cheat them.
Yeah. So
Sometimes.
I want to start closing, but okay.
The only thing I think is important for mistakes is you can learn, or at least an ingredient for being able to learn from mistakes when you're in an educational environment is to have the right feedback at the right moment. If I'm learning to throw a ball to basketball and playing basketball, and I'm trying, say, 10 attempts, then I need to see if it went through or not. If I'm put a band in the eyes and then later on I'm told, yeah, you made right attempt 1, 3, and 7. What is good for me? I cannot learn from my mistakes. Where was I pointing? How strong was
the technique?
Yeah, you need the right feedback at the right moment, and that is an ingredient to being able to learn from mistakes.
So if I were to summarize a bit the main ideas and everything related to education, math, maybe some apply more to students, other to teachers or professors, being passionate, staying curious, working hard, being a little bit humble, I would say, with given the whole idea of mistakes, and making sure that when we make mistakes, that to use them to learn and improve that algorithm. Yeah? So I wanted to open the floor for questions. So we have a few microphones from our team at the school. So if you want to raise your hand and ask the panel, please take advantage of the opportunity.
Hello, thank you very much for the talk. It was great. I learned about 70% of my math not from my teachers. So just going to Google, seeing what other exercises some other teachers have gone through, and also like Khan Academy was very useful as well back in the 2000s or something. So it was a great experience, but I never felt like my teacher was the one that was doing the role. About the AI, I was wondering if you could talk about a little bit about the customized experience that this allows to the student. Having like an adaptive system that learns from that very student and shows them a path with a story, with the examples that connects with them so that they can learn in the optimal way that is good for that student. And I don't know if you have started seeing systems like this or you are expecting them in the next years. How is the field in this? Thank you.
Okay, I think I will repeat something that he said, and is that IA is very weak in logic. And you can't learn really from IA. You can test as a sort of example. But for instance, if you ask them to prove some basic statements in logic, it makes completely wrong statements. And it makes also circular arguments. It's a start from A and end at in A. So you must be very, very careful how you use IA to learn. I think you need to be a little bit more experienced in order to double check some of the statements that it says. When you said you learn more than your 77% of your mathematics, probably that was because when you were looking for those math, you were already experienced with math and you were asking right questions, you were trying to look for answers. This is not the standard position for students. Students, what they expect, or at least how the system works, is that you propose a problem and try to solve that problem with the theory that has been developed, right? But in that sense, we must be very careful about IA because, as I said, in logic, it's really, really weak, very, very weak. For computations, it could be very nicely, and it works. And as he said, it works also with statistics, and in average, it gives you correct answers. For letter of recommendation, the other day someone was telling me, oh no, I introduced some ideas, and then he wrote the letter of recommendation I had to produce for someone else. I said, come on, this is completely ridiculous. If everybody's going to produce a letter of recommendation with ChatGPT, then there's no way to ask for letter of recommendation for candidates. So we must be careful in that. That's my perspective.
There is a big field of adaptive teaching that uses AI. And I think that when you adapt the path or the way of teaching to someone who is learning, that adaptation is based on your knowledge about the student. How deep does the AI know the student? It knows some things on a very surface level. So if you want deeper knowledge, then you can adapt more. And that is the role of the teacher. Say, to know your students in a deep way so that you can adapt the teaching in a deeper way. So adaptive teaching is and adaptive learning is a very good topic, a very nice topic, and a very convenient topic. But I think it's a very narrow meaning of the word adaptive.
Yeah, something that we've also seen searching for tools for our students here has been that there are certain tools that have this adaptive learning. So when a student doesn't do a problem correctly, it can give the option of show me another, so they can iterate again.
Mm-hmm.
And I think we had another question over on this side.
Thank you for the presentation, the contribution. Very quick question. As you said, I feel very much that we are like the dinosaur watching the asteroid. The AI is the asteroid. It is coming. We have seen that there are many institutional problems, structural ones. They are not easy to resolve. So especially for younger people, but for all of us, because we are all in this, what do you suggest to adapt? Because I see there is a very big problem. There is a very big gap between technological development and human skills development. And this kind of disruptive technologies demand an upgrade of our skills, but how to do this while coping with everyday life? Because that's a problem as well. It's like, yeah, I want to learn more about AI, about maths, but I have to do all the other tasks that I do routinely. So that's my question. Thank you so much.
Mm-hmm.
Well, I think you're absolutely right that all universities are wrestling with how to introduce these tools. It's crazy to try and say they don't exist. That's like the dinosaur sticking their head in the thing and say there's no asteroid up there. Yeah, so the thing is how to effectively use that asteroid. You know, is it the fact we're going to mine it? Is it the fact that we're going to use it to generate energy? Or so I think we've got these new tools and they're transformative for society, and we've got to learn how to incorporate those in a way that is going to help you as the next generation to use these. And we don't quite know what this asteroid is at the moment, and that's one of the very unsettling things. And but I do think there's too much of a dystopic narrative around AI, and I slightly think that's being fueled by the tech entrepreneurs who want to scare us that this thing is incredibly powerful, which lifts their stock price because we all think, well, it's going to be really amazing. And I think we need a little bit of understanding that this thing is still just a tool. It isn't conscious, or it's despite the employee at Google thinking his large language model had become conscious. That's pretty impressive that the large language model persuaded the guy to sacrifice his job on its behalf. But I think, we are still in a very transitionary stage. So that's why we need society to be involved in the decisions going forward. So we shouldn't leave it up to just the tech entrepreneurs to, define what's happening. We need everyone to be involved in it. And that's, in a way, I'm a professor of maths. My other job is a professor of the public understanding of science. And that's why I wrote a book about the, published in 2019, because I could already see this is going to have a big impact on society. And I wanted people to understand what this thing is, not just have AI as some two letters that, frighten everybody, but to lift up the bonnet and show what is machine learning? What does it mean for an algorithm to change and learn? And if you have that power, either you're being programmed by the AI or you program the AI. So we want to be in control.
This is also a learning process for everybody. Nobody really knows what's going on or what's going to happen in 5-10 years. And there is a parallel situation, for instance, with the smartphones. If you ask someone about 15 years ago about a smartphone and you say all the utilities, all the apps, everything that you can use with, they would say you will be probably in a movie or Matrix or something like that, right? I think in 5-10 years or 15 years, we will see this conversation and we will say, come on, these guys were completely out, or they didn't know what they were talking about. And probably that's true, right? Because the development would be completely different. This is a learning process. We're learning and we're trying to put that in our teaching skills every day, and in order at least to advise you that, of course, it's a collaborator, but you need to be careful about your collaborator. It's the basic message.
We have some questions over on the left side of the and right side of the room.
Hello. Thank you very much for all the topics that you covered already. As a student, I'm more curious about what is happening around the AI right now, and if you were a student right now and like you're already professionals, you use many tools in your professional life. How can you approach mathematics using the already current tools which are available to the public for using and studying mathematics?
You mean AI tools?
Not only, but in the majority, yes.
The computer tools or?
Yes. Are there any tools that are already available to the public that can help students like me to study better maths?
Well, I think Eva already mentioned the ability to generate examples or interesting examples, and also Marcus mentioned a little bit the fact that they can spot some patterns on data or on your own examples. So that's a good way to use it. But for that, in my experience, I don't use AI. I use a specialized software for that, which is not acting statistically or just guessing. It's something that I conduct the way I want to produce new examples in this direction, this other direction. Because for AI, in my experience, I have little experience with that. It produces information, answers, but doesn't know about which one is more important. What are the important things? So some examples I do algebra. So if I'm generating algebraic examples, and okay, in this direction, I want to look at this direction because these examples are important because they can and cannot have the properties I'm searching for other than just using random examples. Then it's harder to learn from random examples. So even generating examples, in my experience, I put the intelligence in the search of examples, and the computer puts the power to generate them, and the computing power and the automatization of that, the artificial part. So that said, there's also some abilities that we can use AI and machine learning to help our work, like coding, for instance, and it's generating good tests to check whether our code is correct or not, our own code, or not only the code produced by AI, but I think it will improve our ability to develop nice tests to check the truth or the importance of the outcome or of the outcome of an AI program or my own programs or my own productions. So being more clever, designing check or tests to check the importance of the truth of the answers. I think that the word answer is having a new meaning, and that's nice.
So I think we'll take 2 more questions, but if you don't get the chance to ask your questions, we're going to have some time to mingle afterwards, so do feel free to come up with and talk to the speakers.
Thank you for your presentation. I had a little question about the application also of AI in our everyday life. We already know that a lot of companies are working about implementing AI of already existing things as cars or something else. The thing is, AI is doing a lot of errors still. And for example, if I read about a company that is working on a car that is driving itself, vision artificial, how we're gonna approach this margin of error? Because if a car does an error on the road, it can kill someone. But after this error, are we gonna blame the AI itself? How can we blame the AI or the guy that does it? That's my question.
Yeah, I think these are really interesting because the legal implications of AI and in things like generative AI, who's got ownership over creative things produced by the AI? Is it the person who wrote the code? There are a lot of artists saying, but it used my data, that it's learned on my data, so I need to be credited somehow as well. So I think these are, they're really interesting legal questions about ownership of things produced, whether it be death or a piece of art, for example. One of the interesting things that happened in the car industry was, for example, Germany said straight off the bat, if any car, if it's being driven by AI, kills somebody, we as a company are going to take responsibility for that. So and that immediately made people trust cars being produced by that, because they said, we're not going to try and offload it, and it might be a coding error or a learning error, but we are going to take responsibility for that. And that immediately shifted people's attention to German cars, driverless cars, because they made that decision. And other people were, kind of umming and ahhing and saying, yeah, but we didn't really cause that error. The other interesting thing in this respect is that we are demanding a much higher level of safety standard of AI than we do of humans. The first car that killed somebody, the number of times that hours that it had driven and hadn't killed anybody, compared to a human, the average time it takes for a human to kill somebody was way different. It's like saying, I'm not flying anymore because, I saw an airplane come down. And actually flying, is way safer than driving a car. More people died after 9/11 because they didn't take planes anymore and they drove somewhere and they died in car accidents and actually died in 9/11.
Okay, we'll take one final question.
As you mentioned before, a mathematician's job to create a novel with the data that AI can analyze. With AI growing faster and faster, maybe will a mathematician's job be more restricted or shifted towards a more philosophical side? And if that's the case, will that force mathematicians to not only be brilliant at math, but also like subjects from the humanities field, like history or philosophy or language or stuff like that? Thank you.
Okay, I think I doubt really that a mathematician is going to change their way of working, in the sense, of course, this is going to be a collaborator, but still you will try to solve the problems of the millennium. You will try to solve the Riemann hypothesis. You will try to solve Navier-Stokes equation. So there are some approaches to mathematics that IA can be helpful in the sense of, as we said, but really changing our, at least personally, I can say, right? I can test either with software, like he said, or with AI, some sources of examples, but it's not going to change how I face a problem, or I'm a pure mathematician. But I think that's part. Or if you need to solve a applied math problem, it's also, this is going to help you for sure with the coding, with the libraries that is implemented there in order to compute things. But you need to solve finally. You have to use your mind, your eye, in that sense, like he said, right? Your intelligence. So I don't think that, it's not going to finish up our job, I think, hopefully.
Also, there's so many different types of mathematics. This mathematics is so varied. There's so many different ways of doing math that most of them are not affected by AI or computers at all. I mean, most of us mathematicians here, we still work with paper and chalk on the board, and that's why we do. And the other thing is why we do math. AI has no why. It has no intention. It just answers questions. They have no intention so far. Also, why we do math is something that cannot be substituted. I always like to quote Feynman, who said, sorry for the bad citation, but Feynman said, physics, say mathematics, science, is like sex. It has a very direct, obvious application, but that's not the reason we do it. Not the main reason, at least. So math is the same. It has nice applications, solves problems, whatever. I would say we all mathematicians here share the same. It's not the reason why we do it. We do it because it's cool. Come on.
So, please.
Just want to say that I am enjoying every single minute of this. Thank you so much for this really exciting conversation. I wish we don't have time limit, but I just want to go back to the question that the student is asking. And I think that probably what the student meant, and I personally believe, and that relates a little bit to Marcus, what you're saying, that we are, I mean, if we forget for a little bit, this whole AI and, is it taking my job? Is it replacing my, what's it going to do? Are we ready? Are we not ready? I mean, we'll get the hopefully time to answer those questions. But I think that we are in a very exciting moment in the sense that, Marcus said that AI is really good at spotting certain patterns. So if we give it a lot of data, and they can spot patterns that we personally, we can't. So I think we're in a moment in which maybe AI is going to make us smarter, in the sense that if it's able to spot certain patterns that we humans don't see, it's going to be our job, your job as mathematicians or as scientists and teachers to kind of try to find an explanation of those phenomena that hopefully, and I'm being really optimistic for the future, is going to make us smarter, is going to probably give us tools to kind of find solution to some of the problems that for so long, we don't have solution to. So I'd like to kind of just, add something that it's a very exciting time. We shouldn't be scared of AI. It's just a tool. But I hope and I believe that it's going to truly make human, if we know how to use it correctly, smarter beings. What do you think about that?
I think more than smarter, probably profitable in some sense. Smart, I would like to know, for me, there are some mathematical heroes. Okay, one.
And our ability, to kind of explain certain things.
In that sense, more profitable, in that sense, right? You are, there are some mathematical heroes of 18th century, 19th century. If you think, what could, the ability of doing things they were doing just with a piece of paper and a pen, and how they produced wonderful formulas, wonderful theorems, wonderful theories, what could they do with this tool? It would be much more profitable in that sense. The amount of results and the development would have been much, much, much faster. And this is what's going on nowadays. It's connected to the question of the colleague. Now if we learn how to use, it's the example with the smartphone, right? 15 years ago, 20 years ago, you were in a bus stop and you were waiting, and if the bus was not coming, come on, now you have the smartphone, you say, it's coming in 3 minutes, I can, or it's coming in 10 minutes, I can do this, so somehow you take more advantage. And this is what we have to learn, at least from my humble perspective. We have to take advantage of the positive side that IA is giving us. Thanks.
I think there's something interesting that AI at the moment depends on huge amounts of data to learn on. So if you're in an area which actually there's not very much data, for example, very high art, there's not many examples of high or very good music or mathematics. In my area, we just don't have the data for it to even start learning on. So I'm having to generate ideas without any access to really any data. So I'm generating things in a very kind of formal way. So for me, at the moment, AI is not a powerful tool in my area because there's nothing for it to learn on, weirdly. So I'm having to generate new things. So at the moment, so I think it's very interesting. It relates to the previous question that there are some areas of mathematics that are going to be very amenable to AI because there's huge amounts of data for it to look at. But in my area, we just don't have the examples. We're really generating things very much from scratch. And the AI can't do that itself. It can't make the synthetic data, right? So I'm still working with ideas. And the ideas is not something the AI is very good at.
Yeah, understanding AI is also very important in order not to be too naive about it. So let's understand it so that we can drive it instead of it driving us or the companies behind it driving us. So as scientists, I think our goal is or aim is to understand it in order to use it to improve our own capabilities. Otherwise, I think we are too naive. Just to expect big companies, big AI companies to just give it to us so that we can do better our job.
Thank you. We'll finish with Jamal.
Just to wrap up, I just wanted on behalf of the school and on behalf of the university to say thank you. Thank you for what you share with us and to make math passionating. But I wanted actually to ask you a last question, and I wanted to thank especially all the youth that came also tonight to listen about math, which is fantastic and what couldn't make us so excited. So on a final thought, each one of you, where would you like to see a mathematician? In what profession in the future excel? Something that you, about the passion of math, where the math could bring us.
The leader of our country. Prime Minister, yeah.
I think so. I agree.
So I would like in, say, 100 years to see a mathematician working as a pure mathematician. So there's still room for them.
Okay. Well, thank you very much. I think with this we'll wrap up. I know there are remaining questions, so please, with the drinks, come up and speak with the speakers and ask your questions. Thank you.
Thank you. Thank you all very much. And I would just like to say a kind reminder to check in. We have placed a couple of QR codes around the room, so please make sure that you check into the event. And then please go ahead and enjoy a little bit of a catering that we have set up for you.